As per Rankin's theory of earth pressure, the inclination of failure planes is 45 plus phi by 2 with respect to the direction of the minor principal stress. The above statement is correct for which one of the following options? Only the active state and not the passive state, only the passive state and not the active state, both active as well as passive states, neither active nor passive state. Okay, so here it is asked that the failure plane, suppose if you take any sample or soil behind the retaining wall, okay, so if this is the retaining wall and this is the soil, so soil fail about a plane. So in the soil sample also, if you take an element, it fails about a plane. Okay, now the angle, okay, this angle, suppose this is the minor principal stress direction, that means like this. If this is the direction about what is that, inclination of the failure plane is 45 plus phi by 2, 45 plus phi by 2 with respect to the direction of the minor principal stress. Let us say this is the minor principal stress direction, okay, and with respect to that 45 plus phi by 2 is the angle of inclination of the failure plane, just like that. So suppose this is the minor principal stress, so this is the direction, right, these are parallel, so this angle, okay, this angle is 45 plus phi by 2. Here it is said whether this is in both active state and passive state or one of them, that is the question. So we need to know what is Rankin's theory about. Okay, now so I'll introduce Rankin's theory is for cohesionless soils. Okay, that means phi is not equal to 0 and C equal to 0. Next, give me a minute. Yeah, next what we have to know is what is active state, what is passive state. Okay, so in the active state, retaining wall moves away from the soil. If this is the soil, it moves away from the soil, that is active state. Due to that, soil fails. Whereas in the passive state, so let us consider two different heights of the soil. This is retaining wall, okay. So now due to this it moves this direction. Because of that, now with respect to this soil, it is moving away from the soil. With respect to this soil, this side soil, it is moving towards the soil, okay, towards the soil with respect to this soil. So whenever it is moving towards this, this is passive state, this is active state. Okay, so now this is active state because there is no soil and it is moving away from the soil, so this is active state. Now see, in the active state, in this active state, see, if you take an LE element, sigma H, sigma V, sorry, sigma H, sigma V. Here also if you take any element, sigma V and sigma H. In the active condition, at failure, sigma V is greater than sigma H, because soil is moving away from the soil, sorry, retaining wall is moving away from the soil. Because of that, the at rest sigma H gets released some that will be relieved and it slowly decreases. So at the failure, the final sigma h value will be less than sigma v. And here in passive condition at failure, sigma h will be more than sigma v. Okay, you should remember this, because when it is moving towards the soil sample, so toward the soil, so if you take sigma h, sigma v, so this will increase because of the movement of the wall, it is increased. So at the end, sigma h will be more than sigma h at failure in the passive state. So before that, so once you know these two things for the active state and passive state, and cohesionless soils, that means C equal to 0, so rough Mohr Coulomb's failure envelope I can roughly draw. So it passes through the origin because there is no intercept, because C is 0, okay, and it has angle phi. Now there is Mohr circle, it touches at one point. So this is minor principal stress, this is major principal stress, this is sigma axis, this is tau axis, okay, this one is tau axis. Now, so this is the Mohr Coulomb failure envelope as well as Mohr circle, as well as a Mohr circle for the cohesionless soil. If it is cohesive soil, there would be the Mohr Coulomb failure envelope would be like this, okay. If it is C phi soil, it has some C as well as it has some phi. As it is cohesionless, it is passing through the origin, okay. Now here one more thing you should know, that in this active state, passive state, the vertical stress and horizontal stresses are principal stresses, because there is no shear stress on horizontal plane and vertical plane. There is no shear stress. Because of that, these two horizontal and vertical stresses are principal stresses. So whether it can be sigma h or sigma v, it can be sigma h or sigma v. If it is sigma h, it will be sigma v. If it is sigma v, it will be sigma h, right, like that. So one of them will be major, one of them will be minor. So now let us go for the active condition first, okay, active condition first. So I'll draw the Mohr circle. Sorry for the bad diagram, okay. In active condition, we know sigma v is greater than sigma h, so this should be sigma v and this should be sigma h, and this is phi, okay, this is phi. Now this is circle, okay. Now where is sigma h is acting? Sigma h is acting on vertical plane, sigma v is acting on horizontal plane. So first there is a concept of pole. If you know, if you don't know, you can go through any YouTube videos or anything, but still I will explain roughly here. Pole is something which is used to find out the angle between the angle of the failure planes or angle of any plane actually. Suppose, see, this is the failure point because Mohr circle is touching the failure envelope. So this is the point which is representing the failure plane. So now what do I do? If you draw a line between the pole and this point, that line will show the angle of the failure plane, because this is the failure point, and the line between the failure point and the pole will give you the angle of inclination of the failure plane with respect to which plane, that I'll explain now, okay. Now first let us find out what is pole here. So finding the pole, you can find out like this. You know the stresses sigma v and sigma h, right? So sigma v is acting on horizontal plane, sigma v is acting on horizontal plane. So what you have to do is you just have to draw horizontal line through sigma v, So I am drawing, let me change the color. Let me change the color. So I am drawing a horizontal line from sigma v. So sigma h is acting on vertical plane, so I will draw a vertical line from sigma h. So the point of intersection of these two, that is the pole. This is pole. Okay, that is how you should find out the pole. Now what did I tell? If you draw a line between, so let me erase this. I'll draw in. So first let me draw. So this is pole. Now if you draw a line, so I'll draw a line between pole and failure point. So this line will give you the angle of inclination of the failure plane. So but angle of inclination of failure plane with respect to what? With respect to, suppose if you are calculating this angle, this is the angle, let us say this is the alpha f, failure angle. So from where you have taken this angle? You have taken this angle from the horizontal line. That means in this soil element, okay, here you can say from the horizontal line or horizontal line, if you draw this, which is a line which is having same angle with of this alpha f, this is the failure plane. You can represent in this. You can directly use protractor and find out the angle with respect to horizontal plane. It is making this angle. Suppose you want with respect to vertical plane, so you just take this angle. So this is the angle with respect to the vertical plane. So that is how pole will be used, right? Suppose you want with respect to this failure plane angle with respect to a plane which is at an angle of 10 degrees with respect to horizontal. Suppose somebody is asking angle of failure plane with respect to a plane which is 10 degrees to horizontal plane. What you have to do? You have to use the pole, that's it. Now first draw this 10 degrees to horizontal. Okay, I'll draw a 10 degrees line first with respect to horizontal. This is a horizontal. With respect to horizontal, I'll draw a line first, okay, with 10 degrees angle from the pole. So now this is the plane. With respect to that plane, what is the angle of failure envelope? Now you draw from the pole, you draw a line to the failure point. This is failure plane. Now if you find out the angle between these two, that is the required angle. Okay, this is the required angle, alpha required. So that is how pole will be used. Now anyway, I'll draw another clear diagram. We know in the active state this is sigma h and this is sigma v, and this is the pole, right? This is the pole, and let us find out this angle. So this is phi, this is phi. if this is friction angle, right, this is phi, means this is phi. If you know this one is, let me change the color, this is 90 degrees. Why? Because this is tangent to the circle. So, and why this is 90 degrees? Because this is the line between the point of intersection of the tangent and circle to the center of the circle. This is center of the circle, let us say. This is the center of the circle. So, it is 90 degrees. This is the one of the rules or laws of the circle and the tangent. Now, if this is 90 and this is phi, and what is this? This should be 90 minus phi, right? Because this is 90 and these two angles, this angle and this angle should make 90, total 180. If this is phi, okay, because of the angle of inclination of the Mohr Coulomb failure envelope will be phi. So, now this is 90 minus phi. Now, in this, this is O, C, let us say this is A. Let us say this is P. Now, in this, I will take another color for these two angles, and in the triangle PCA, in the triangle PCA, in the triangle PCA, PC equal to AC, because PC is also radius, AC is also radius, right? Implies angle APC equal to angle CAP. This angle and this angle both are same. Let us say I will give this as alpha, so it should also be alpha because of this, okay. And we know this angle from 90 minus pi. So, let us find out what is alpha. So, 180, sum of all the angles in a triangle should be 180, alpha plus 90 minus 5. So, 2 alpha equal to 90 plus 5, then alpha equal to 45 plus phi by 2, okay. So, this is 45 plus phi by 2. So, now we know the angle between the failure plane, this is the failure plane and this is horizontal plane. Angle between failure plane and horizontal plane, I know the value is 45 plus phi by 2. But what is asked in the question? In the question it is mentioned that you need to find out the angle between minor principal stress direction of the minor principal stress and the failure plane. So, in the active state, this is sigma V and this is sigma H. So, what is minor principal stress in the active state? Sigma H is the minor principal stress. This is major in the active state. So, what is the direction of the minor principal stress? That is horizontal direction. So, here with the horizontal, if it is making, failure plane is making alpha equal to 45 plus phi by 2. That means the angle between failure plane and minor principal stress direction, okay, that is horizontal, stress direction is 45 plus phi by 2. In the active state it is true, the question is true in the active state. What about in the passive state? Let us try that, okay, let us find out, okay, in the passive state. So, in the passive state, this is sigma V, this is sigma H. As we discussed, sigma H is more than sigma V in the passive state, okay, and for that sigma H will be here and sigma V will be here both are principal stresses because no shear stress is there, and this is the failure point because it is touching the Mohr Coulomb envelope, and this is O, center is C. Let us say this is A. Okay, let us say this is A. Now we will know, first we will try to find out where is the pole. Okay, so for that let me take, see how to draw the pole. First, sigma is V is acting on horizontal plane, sigma V is acting on horizontal plane, sigma V is acting on horizontal plane. So I will draw a horizontal line along the sigma V. Sigma H is acting on vertical plane, so sigma H is acting on vertical plane. So I will draw a vertical line through this sigma H. So this point of intersection is pole. Now from the pole you need to draw line between failure point and pole. So this is the failure plane. Okay, now what is this angle? This is the failure plane, the inclination of the failure plane with respect to horizontal, right, in clockwise direction, any direction, but whatever it is. And what is this? The failure, this is with respect to horizontal plane. Okay, and this is also failure angle. Let us say this is also alpha f, but with respect to vertical plane. That's it. Okay, that is what the pole concept. Now, so I'll just complete this. I'll draw a line between this sigma V and sigma A. So just now we found out what is this. If this is phi, and this will be 45 plus phi by 2, right? And see, in a semicircle, what is the angle? If you draw two lines from the two ends of the diameter of in a semicircle, and wherever they are touching, that will make angle 90 degrees. So this we all must be knowing. And this is 45 plus p by 2 because we have derived that. Now what is this angle then? This angle should be 45 minus phi by 2. Okay, so now we understood this is 45 plus phi by 2, this is 90, this is 45 minus phi by 2. And what is this? So if this is vertical line and this is horizontal line, so this is vertical line and this is horizontal line. So this failure plane is making 45 minus phi by 2 with horizontal. So then it should be 45 plus phi by 2 because 90 minus this much. Now we will find out. So what is the sigma V, sigma H? So what is the minor principal stress among these two? This is the minor because sigma V is lesser than sigma V. So this is minor. What is the direction of minor principal stress? Vertical direction. So vertical direction. With vertical direction, again failure plane is making 45 plus phi by 2. So here also the angle between failure plane and minor principal stress is again 45 plus phi by 2. So that's how we'll go back and see above statement is correct for which one of the following? Only active state, only passive state, both active as well as passive. So answer is C.